All right, thank you guys for joining us for our mechanical engineering senior design presentation. This is our senior design project from fall of 2023 to spring 2024. We are the spring rate measurement of a pneumatic mountain bike tire team. My name is Joseph Balderrama,
My name is Lukey Rosen.
My name's Duncan White.
My name is Alex Koshlikov.
and our project sponsor coach was Dr. Yannick Song, and our surrogate sponsor is Dr. Andrew Keene. Moving on to our poster, we're just going to do a quick little overview of our background and objectives. So we were tasked with developing a device that would produce a more consistent parameter way of parameterizing our tires based off the spring rate rather than its internal pressure. Our design went on three main iterations. It had a first edition was a double-sided wheel stand, and then it went into a single-sided beam style load cell, but we were worried about not being able to withstand the force. So we're moving on to our current final design, which is the single-sided framing with an inline compressive load cell, which we are using an LCM 200 load cell, generously donated by FUTech. That meets our design specifications. So we're super grateful for that. And then moving on to the electronics.
So our electronics design was centered around an Arduino Uno microcontroller, and coupled to that microcontroller was the FUTech load cell, a load cell amplifier, a potentiometer, an on-off switch, an LCD screen, and a test reset button.
And for the manufacturing, we used mainly 3D printers, lathes, and mills. For the lathes and mills for all the metal, aluminum, and steel components, and the 3D printers for all of the components that used PETG.
The main component that we analyzed was the wheel axle. And the purpose of that was that minimizing the deflection of the wheel axle was crucial to obtaining accurate spring rate results. We analyzed it in SolidWorks FEA and modeled the wheel hub as a distributed load on the axle. In terms of testing, we had three main tests that we wanted to be within. We had test variability, weight, and force capability of the load cell. And we were within specification for all three of those tests.
So now that we've completed the project and have a fully functioning device, there's a few recommendations we have going forward that we'd like to implement. One is to make the force application a little bit more constrained in basically one direction, so there isn't any out of plane loading. And then make it a little bit more user-friendly with a few more buttons and maybe a screen that can display more information or even display a graph of the spring curve rather than a singular value. And here's a video of me demonstrating how to use it. Unfortunately, we had a little bit of a technical difficulty with the audio, so I'll just narrate over it. So there's an on-off switch, the toggle that was mentioned earlier, that turns on the electronics inside the Arduino. Goes through a short initializing phase, after which it's ready to collect data without doing anything else. In a moment, you will see me remove the wing nut and wheel spacers and mount the wheel on the axle through its hub. The spacers are used to accommodate different widths of mountain bike hubs, depending if it's a front and rear wheel, and then a few other random standards. So you put the wheel on, reinstall the spacers, tighten the wing nut, and in a moment you'll see me press the test retest button. In this configuration, we just have it in kind of a demo mode. So it's a very small displacement that we've programmed into it and a short collection time, just to make displaying it and demoing it for people a little bit quicker. And the displacement is fixed and it's used to calculate the final spring rate. Here you see me advancing the tire contactor into the tire, which deforms the tire. And the maximum force value detected by the load cell is then used in conjunction with that fixed displacement to give you a spring rate, which is displayed on that LCD screen.
And just some acknowledgements here. Jim Collins was who we contacted to get our initial load cell, and then we reached out to Wade, and he was able to get us in contact with FUTech to get our inline load cell. And Dr. HP was also very helpful with some design direction and kind of guidance on our design once we got the FUTech load cell. And obviously, huge thanks to FUTech for donating the load cell. Couldn't have done it without them. And some other contributors were SRAM and Specialized for the tires. So thank you to all the people involved and people who supported us. Couldn't have done it without you guys. Thank you for watching, and be sure to read the poster and the report for more detailed information on the project. Thank you.